Hi, I'm Guru Rajan from Algoo Solutions. This is part 2 of our detailed description of the state design pattern. Alright, let's look into a real example for a design pattern in implementation. Because we are so accustomed to calling each other and speaking over phone, let's take a phone call and see how the states and patterns match here. In a phone call, so before that we just want to say that there is an entity here which has states, and from the external world you get events, and then it goes to another state, that is, there is a transition, and while doing this transition it also actually executes a behavior. There is a behavior. Now for a state pattern you have a state, an event, a transition and a behavior, right? Having known this, in a phone call, if you talk with each other, what states you will have? So let's actually enumerate the states. The phone can be idle, so nobody is talking, so the phone is just idle, right? And once, what event you will get? Okay. The terminology is slightly dated because you always talk about lifting the phone from the receiver, so you just say off hook. So once you take the receiver off hook, actually you get a dial tone. Dial tone is a state, right? Once you are in dial tone state, you dial the digits, right? You dial digits. So you are doing some act, you are producing an event by dialing the digits. Now you dial digits. Now once you dial digits, there is a ringing on the receiver side. The ringing on the receiver side is heard by the caller, and that is called as ring back. So dial tone is also called ringing tone or whatever, ring tone or dial tone. This is ring back. See, you dial digits, the other guy's phone is ringing. For you, you are hearing it as ring back in your receiver, that is caller. For the caller it's a ring back. Once the other guy lifts the receiver and says hello, then he is answering your call, and that's an event. Remember, this is a state, this is an event. Right. Now, whether you hang up first or he hangs up first, there is a hang up. It depends on how long you talk, depending upon how good you know each other. Well, that's fine. After all that conversation, you just hang up, right? So you hang up. So you produce an event, and then when you answer, please understand, when you answer, there is a two-way talk. Sometimes if you don't like each other, there's two-way noise actually, but fine, if you like each other, it's a two-way talk. So once you hang up, it goes back to idle, right? It goes back to idle. So you are in idle mode, then you get a dial tone, you dial digits, it goes to ring back, the other guy answers your phone, it's two-way talk, you bang the phone down and then it goes back to idle, right? Now, somebody has to take some action inside the software that is written for the phone. It's a digital phone, right? So you have to take some action. So, right, and also, please understand, you are in idle mode, you get this event, you go to dial tone. You dial digits. When you are in dial tone, you get this event, dial tone, then you go to ring back. There is a state transition, right? Now the guy answers the phone, there is an event, and you go to two-way talk. This is state transition. The curved lines represent state transition, and then you hang up. What happens? You go back to idle. The phone is idle again. Now while doing this, there are some activities, right? So you have to handle the event. So this is state, event, state transition, and then action. What is the action you take? So action can be handle off hook event. Handle off hook event. Now this is how software is written. Handle off hook event. Handle dial digits. Remember, I am oversimplifying it just for understanding this design pattern. The functions will be different very widely inside your code. For example, people who have written software for the state machines inside a telephone exchange, for example, will know a lot about this. But fine, this is a general state machine code, and then you handle answer, handle dot dot dot, and then you handle the other one, right? So these are the actions. Now you compare this with what we wrote for the state machine design pattern in our earlier video. We said there is a state base class. There are as many derived classes as there are number of states. We have a context class which actually takes input from the client and then passes it on to the base class. Through the base class you actually call the behavior. Now there is a state transition which is actually a two-dimensional array. Don't get really puzzled by this state transition. It is nothing but a two-dimensional array where you have coded the state changes in terms of an hash define or a enum which you have done in the .h file. Now I am just going much deeper into the implementation now, just for you to get a hang of the things. Right. Now where is where located? Now these states are located in your context function. The context actually has a record of these states. Right. Now who does state transition? It is the context class that does state transition. And who has all these behaviors? Now please remember, what did we say as a definition for the state pattern? The object alters its behavior based on the current state. Please get this right. The object alters its behavior based on the current state. Now, the same behavior with the same name with different implementations of these actions are written in the derived classes. The name will be same, but the implementation is different in the derived classes. Why? Because each derived class represents one state. So obviously, based on state, the implementation has to differ. Why does it differ? Because that's what the pattern says. The object changes its behavior based on the state. Now, that change in behavior is coded in the derived classes. Correct? The base class, what does the base class state have? It has actually nothing. It has these handle off hook event, handle dial digits event as an empty implementation. Right? So the base class only has an empty implementation. The derived class actually has the real implementation. Now the context has a record of these states. The context also has that two-dimensional array which actually does the state transition. Remember that two-dimensional array which we talked about in the last video? Okay. Now who calls these behavior in the derived classes? Somebody has to call, right? The client gives, so what does the client will be calling? Client will say, client's function will be coded like this. I'll just write, the client will say handle off hook. Okay, and it will pass an object of the context class, that's all. Okay, so handle off hook, but I don't know, client doesn't know what state the system is in. In fact, it doesn't need to know. I mean, that's where the OCP comes about. The client just says handle off hook. Context knows what is the current state of that system, and based on that, the appropriate derived class behavior will be called. Now, this is how a real software implementation works, and I hope you got an idea of how this implementation is. So as usual, we talked about a base class which has the interface and the derived class which has the actual functions. Do we have some real world examples for the state pattern? Of course we do. Now, have you seen these decorative fans in these fancy lights shops, or in the any of these fancy shops that you have been? So there is a thread which you pull, and then there will be a light which kind of a dome which hangs from the center of the fan. Right? Have you seen that? I hope some of you have seen. So if you pull a thread, first the light will be on. If you pull the thread again, the fan will start to rotate. If you pull the thread once again, the fan will rotate in second speed. If you pull the thread again, third speed, final speed. Now after the final speed, if you pull the thread again, it actually switches off the light and fan both. Now again if you pull the thread, light will be on. Now pulling the thread is the same event, but the action taken by the fan system is different based on the current state, whether its light is on, whether it is in first speed or second speed or third speed. But you are doing the same event, you are giving the same event, pulling the thread. Doesn't it look like a state pattern? Maybe it does. Just put your imagination to work. And I do sometimes believe that our entire life runs on a state design pattern. Sometimes when you are very young, we get an offer for a job, or if you are a Harvard graduate, you get the offer to be a VP at a very young age for a startup company. You don't take that. But once you become aged, you get if you have got the same offer, you think that maybe I should have accepted it. Now what has changed? Your state has changed, but the event is the same. Initially you didn't do anything, but now if you had the same offer, you would have taken it. A lot of people who are older now say that I should have taken that offer in the startup. That's fine. So the event, when it comes in different states, same event, but the behavior is different. And the example for the fan came from the non-software design patterns example page. You will see that in some of the pages. It's not my example, it's available on the internet, the idea of pulling a thread in a fan. So I hope you had an idea of the state design pattern and also how it's implemented in object-oriented programming. And yes, you should have thought about now how is this extensible? Of course it's easy. If you want to add a new state, you add one more derived class, implement all these functions in the derived class, that's about it. But some of you might also be thinking, okay, state is fine, but what if I add one more event? If I want to add, for example, in this phone example, what will be the new state? Can you think about it? Suppose you want to put your phone on hold and dial digits and then invite a third party. What will be that change? So state will be hold, dial digits is the same thing. Okay, then you might move to two-way talk or three-way talk. Probably two-way talk can be extended to have conference, right? That's fine. Adding a state is fine. But what about adding an event? What about, for example, I want to send an SMS while I am on call. Can you do that here? In this system of design pattern, that is not possible because adding an event will change the whole chain of derived classes. You may have to do that in every derived class, which actually violates what? Violates OCP. Actually it violates open close principle because you are not just extending, you are modifying, which is actually what Uncle Bob says. What he says is every design is done with a specific change in mind. It is not designed so that any change can be accepted in future. This design is acceptable if there is a state change, but if there is an event change, you may have to change again. Probably you should have designed it in a different way. I am not saying it is not possible, but you should have done it in a different way. This particular design is not amenable for that. and that's what is called as strategic closure. So you are strategically closing for that particular design change. I hope you had an understanding of the state design pattern. Hope you enjoyed this video, and I did in explaining in whatever detail it is possible over here. Thanks a lot, and we look forward to seeing you in our online training in Algoo.in. You can get more information of the training for the complete 23 design patterns. Looking forward to meeting you there. Let's hope we cross paths again. Thank you. Have a good one.